All right, hi ladies. In this video, we are talking about changes of physical states. Our first change that we're going to see is heat of vaporization. So heat of vaporization is the amount of heat required to vaporize 1 gram of a substance. So vaporizing, we're going from a liquid to a gas. So think of evaporation, liquid to a gas. So our heat of vaporization is the energy required to get that liquid, those liquid molecules, to change into gaseous molecules. Okay, we're going to be doing some calculations in example number 17 and 18. So in example number 17, it says, calculate the amount of water in grams that can be vaporized at its boiling point. So boiling point is the point where we're changing from a liquid to a gas. Boiling point is that temperature at which we're changing from a liquid to a gas. So basically, heat of vaporization is what we're looking for. With 155 kilojoules of heat, we're given the heat of vaporization of water. That's 40.7 kilojoules per mole. So we are starting with our, grab another piece of paper here. We're going to be starting with our single digit number because we need to convert that. We're going to hold off on using this heat of vaporization because we need those moles there in order to get to grams. So we're starting with our 155 kilojoules of heat. We can go kilojoules to moles using our heat of vaporization. So that's our first step. So kilojoules is up top. So in order to cancel it, we need to put it on the bottom. The number 1, so 1 mole, always goes with our unit on the bottom. We need to remember that. And then our next step, so after we've canceled out kilojoules, we need to cancel out moles and then go moles to grams. So we have a conversion of moles to grams, and we're using our molar mass from our periodic table. So we are not given that, but we can calculate that using hydrogen and oxygen on the periodic table. So if we're adding up two hydrogens, so 1.01 times 2 plus oxygen, 16.00 grams per mole, is going to give us 18.02 grams per mole for our molar mass of water. So notice kilojoules was canceled out, moles have canceled out, and we're left with grams, and we want to know the amount of water in grams. So we're in our correct unit for our answer. And you can put that in your calculator, so multiply across and then divide by the bottom. We get 68.6 grams of water that can be vaporized at its boiling point with that much heat. Alrighty, let's look at example number 8. So example number 8 says, how much heat is required to vaporize 55.7 grams of acetone at its boiling point? Again, boiling point, we're going from a liquid to a gas. And we're given our heat of vaporization of acetone. So that's 29.1 kilojoules per mole. So again, we're going to start with our single unit, and we're going to convert from there. So here we're starting with 55.7 grams of acetone. So acetone, we're in grams now, so we need to convert to moles before we can even use our heat of vaporization. So we're basically working backwards from what we did in example number 17. So we are going to get the molar mass of acetone, so add up 3 carbons plus 6 hydrogens plus an oxygen, add up their molar masses, and we will get 58.09 grams in 1 mole of acetone. That's our molar mass of acetone. So we've canceled out of grams, gotten out of grams, we're in moles. At this point, we get to use our heat of vaporization because we got moles there. And we want to go to kilojoules, how much heat? Kilojoules is a unit for heat. So moles is up top now, so we need moles on the bottom, kilojoules up top. We put the number 1 with mole because it's our unit on the bottom. The bottom unit always has an invisible 1 out in front of it. We put this into our calculator, and we get 27.9 grams, kilojoules. 27.9 kilojoules as the heat required to vaporize that many grams of acetone at its boiling point. So just basic conversions like we've been doing recently. Okay, Next, we're going to be talking about heat of fusion. So heat of fusion is the amount of heat required to melt 1 gram of a substance. So melting, we're going from a solid to a liquid. Think about melting ice. So the name heat of fusion isn't as obvious as heat of vaporization, as vaporization is a liquid to a gas. Heat of fusion is a little bit, the name is not as obvious. Okay, so let's look at example number 19. So calculate the amount of ice in grams upon melting, or that upon melting absorbs 237 kilojoules of heat. So we're melting, so that means we're going solid to a liquid and we're using heat of fusion. So we're given a number. We're given 237 kilojoules of heat. So that's our number that we're going to be starting with. So 237 kilojoules. It's also a single unit. We're going to start with those typically. So that means we need to cancel out kilojoules and go to moles using our heat of fusion for water. And from moles, we can get to grams. So we're going kilojoules to moles, moles to grams as our layout for our units here. In our problem, like in our word problem, we're not given the heat of fusion for water, but it's up here in our table. So right here. Heat of fusion of water is 6.02 kilojoules in 1 mole. Heat required to melt 1 mole of water. So kilojoules goes on the bottom in order to cancel, and we're going to moles. The number 1 always goes with the bottom unit. And once we're in moles, we can get to grams using our molar mass. So we've already done water in example number 17. So we already added up those hydrogen and oxygens, and that's 18.02 grams in 1 mole of water. So kilojoules cancels, moles cancel, and we're left with grams, which is what we want to know, the amount of ice in grams. So we put this into our calculator, and we get 709 grams. So far we've had 3 sig figs on all of them, because that's our numbers that we've been given. Okay, example number 20. This one is not a math problem. So example number 20, is energy absorbed or released during condensation? Is energy absorbed or released during vaporization? And how are these processes related? Okay, so let's look at it this way. So condensation, we are in condensation, we are going from a gas to a liquid. Condensing, going from a gas to a liquid. In vaporization, we are going from a liquid to a gas. Let's talk about the energies, the kinetic energies of these types of molecules. So gas molecules, they have our highest kinetic energy. Gas molecules are moving really stinking fast, and they're constantly moving, bouncing off things. They have a lot of empty space in between them. They can move around a lot. So these guys have high kinetic energy, Ke. Liquid molecules, relative to gas, they have a lower kinetic energy. They don't move around as much. They typically stick together. They can still flow. They're still moving, but they don't get to move as fast as our gas molecules. So likewise here, our liquids, they have lower kinetic energy. Solids would be our lowest, and then high kinetic energy. So let's think about it this way. Here, if we're condensing, going from a gas to a liquid, we're going from high kinetic energy to lower kinetic energy. Isn't energy technically leaving our system that we have here? So we're going from higher energy to lower energy. So this is exothermic. Energy is leaving our system. Exo, exiting, thermic, dealing with energy. Okay, so likewise with vaporization, we're going from lower kinetic energy to higher kinetic energy, which means we have to put in energy in order to get there. So this is going to be endothermic. energy has to be put in, so energy is absorbed. If I could spell absorbed, that would be nice. Absorbed. And how are these processes related? Aren't they basically the opposite? So gas to liquid condensation, liquid to gas vaporization. So if we're going from a gas to a liquid, energy is being released. We're going from high kinetic energy to lower. And then vaporization, energy is being absorbed. We're going from lower kinetic energy to higher kinetic energy. So at this point, you can do the heat of fusion and vaporization worksheet.